Welcome to round 2 of the lathe tooling thingamabobber. In last night's episode, you saw this get finished, and in today's episode, we'll be manufacturing the side block out of this lovely piece of 6061. Yeah. I also realized the main block's made out of 70 series, so that's cool. Alright, same thing. Let's go over the CAD, and then we'll get right into it. Yeah. If you're wondering what that buzzing noise is, it's the phase converter, so no, I'm sorry, I can't take it out of the audio, but that's what it is if you're wondering. I'm not sure why, but this microphone fixed it up rather well. Okay, so like yesterday, this is the side block. As you can see, I added some fillets to the edges because I wanted to machine the block up like this and go from the top down like this and then do the drilling tapping first. Then when I go on the side and then bore the holes, it would clean out any burrs that would be left from the tap. Well, this is 2 inches long. Sorry, it's 1 1/4, but the sorry, not that. This distance to this distance, this face here, that's 150, and the 5/8 tool I'm using is a flute length of 1 1/4, so the max I can cut is 1 1/4. I did just order one reduced shank end mill because they're so expensive, and I don't use them very often, so I just ordered one. Inevitably, what happens when you order one thing, you break it like the first time. But anyways, so basically now I'm going to machine from the side because it's 1 1/4, so that's our flute length, and I just added these fillets to facilitate it not wanting to jam itself in the corner and chatter like it did yesterday. So that would just kind of aid in that. Alright, so for Op1, we're starting with a 2x2 piece of 60 series aluminum. So we're going to face down the block. Let me turn on in process. In process is awesome, the stock thing. Face down the block, adaptive obviously around, then we're going to contour and finish it up. Cool. We're going to pre-drill, or we're just going to drill to help in our chip evacuation when we go to bore these out. Then we're going to bore them out with the 5/8 tool, and what I'm doing is because the bore diameter is so thin and it's probably going to go pretty quick. Usually I like to see chip recutting here, depending on how much coolant flow you have, so this would be kind of a good thing to have, like a through spindle coolant kind of thing. So what I'm going to do, since I don't have that, and this is the best idea I came up with in the shortest amount of time, I'm just going to bore half the hole, and then there's a second bore that's the next half. So basically it's going to retract out, and that's going to allow the coolant to get in there and flush any chips out. This is probably a giant waste of time, but anyways, I'm going to try that. Then final contour. These need to be 3/4 because this is a tool diameter, and it needs to be pretty precise, but not as precise as if you were making this for lathe, because obviously a 3-axis mill, we have Z height adjustment as opposed to a normal 2-axis lathe. So as long as these are straight, and they don't basically need to be as precise as you would for a lathe. You need them to be. Then we're just going to chamfer, finish it up. That'll be all good. Then for the flip, basically do the same thing as yesterday. Stick a gauge block or something and just find the side. The nice thing is this thing doesn't stick that far out of the vise. This time, instead of contouring the block, the stock is actually going to be square when we get here. And there's no way to select the stock as a contour unless you draw a sketch or something. So I'm just going to use a 3D adaptive, and I just told it to go from model height and then just down 3/8 or something. So it's basically going to adaptive clear away that top hat, and I left enough material on this side, this flip, to where it won't chatter on the hat side. I think this is a 1/4 inch thick. Yep, so then you want to leave radial material so you don't hit your part. Face down the rest. I would go from the X direction, but like I said, the chuck's in the way of the 4th axis, so you just want to be careful. And yep, then obviously final chamfer, make it all nice. Then we get to OP3, which is going to go back into, hold on, this is kind of weird. This should be, okay, it's correct. So we're going to go back to that default G54, which is top of the parallels is your Z height, and then I'm going to just reprobe it in the center. We'll have a done block at this point. We're going to spot drill because we're going to form tap. Then we're going to spot drill these because I just felt like doing that. Oh, because the chamfer tool doesn't reach down there. Then we're going to drill, form tap like yesterday. We're making sure to go into the hole and make sure we get full thread depth unlike yesterday on our holes. So the reason I wanted to avoid this is because when the drill and the thread mill are going to come in here, they're going to want to squeeze material into our bore, and that is going to be a problem, and deburring it's quite a problem too. So then we're going to chamfer this edge. We're going to come in with a lollipop end mill, and this is one I use for the knife part, so it's really tiny. And we're actually going to use flow and attempt to deburr the backside. I've never done this, and I got some help from Proteum Machining. He's on Instagram, so you should give him a follow. But basically, like, there's a couple of things you have to do to make this kind of work as good as I'm hoping it's going to work, and this is what we're left with. So just as an example, I'll show you the simulate, and we got analysis, and turn off the stock. So this is going to come down. It's very close. It's very close, and then it's going to do that. And hopefully that'll be one good deburr we all need. But this is I've never done this before, so this is all see the pants type stuff. And yeah, that's it for the cam side. So let's go back to real life. Okay, so we got our block loaded up, like I was saying. It's 7 inches wide, so it's a lot less overhangy than the other deal. So we'll go ahead and probe in XY because Z is the top of the parallels like yesterday. So we don't need to mess with that at all. How dare you? Also, I cleaned the windows up for you guys. Alright, I'm going to probe this in and then we'll get started. Alright. The man, the myth, the legend, the Mitsubishi ASX that I crashed and probably put out of balance for that white stripe that's in the middle of it. Oh well, still these pretty good finishes. Good. Did I tighten the vise? Oh, that was fun. Gotta be careful with this because it's gonna go down on the right side. I'm just gonna make sure it's not gonna hit the fourth. Looks good. Smoky. Man, these are pretty thick. Sweet. Okay, now we're gonna do that drill thing I was talking about. Hopefully we don't lose the drill. That would not be good. Oh, I heard it rubbing. I think it's hitting the flutes, that's why. Yeah, I should probably run a longer drill. But oh well. Hopefully that OL doesn't bite me in the ass. Definitely a little too deep for that drill. He was too slow. But yeah, it was definitely too long. It's probably a 1-inch flute length is probably why. And I was going down, you know, 1.25 inches. She lives another day. So now we're gonna bore, which I'm not entirely sure how this is gonna go, but you don't know until you try. Turn the feed rate down a little bit. Yes, chip recutting. That's what that noise is. A smaller tool would have been much better for this, allow the chips to escape, but like I said, the flute length is the problem I'm dealing with right now. Alright, contour, -5 axial, so might rub, I'm not too sure. That sounded okay. Definitely the plunge speed's a little low. Also doing a repeat finishing pass because I figured there'd be quite a bit of chatter on the walls there. And there probably still is. Okay. Tool still looks decent. Hold on, let me blow this out so I don't get it all over the camera. Well, the finish came out pretty good. Not bad, not bad. Let's see if the tool fits. Nope, miles away. Sweet. So I'll come back after and bump that at the end. Next is the chamfer, which is kind of boring, so I'm just going to go ahead and skip that. Alright, got it all comped in, so here's the example. Very nice, very nice. There is a little bit of side to side, like really not much, so they're going to get clamped or pushed up against the sidewall via some screws. So I think... Really? Alright, so we're moving on to OP2. So I was originally going to use this left side, left side to probe for using offset 11 is usually what I use for like an OP2 kind of thing. So what I'm going to do, because of that overhang and I don't want the tools coming close over here, I'm just going to use this side. So I'm going to show you guys what I do when I'm able to actually get to the side of the jaw there. So we got a gauge block here. This is just a 1/2 inch. It doesn't matter which one you use. And what I'll do is I'll stick the gauge block along the edge of the vice jaw that the part is up against, and then I'll square the two so that you're touching the jaw and the side of the part, and just push each other until they're parallel, and then I'll shut the vise. And then basically you can just probe the edge of the jaw, and that'll be exactly equal to the edge of your part, and you can set your work coordinate system to that corner. So we're just going to do that for that, and then we'll start doing the OP2 stuff, the rough and then the face, and this one's pretty easy. A little close, but this is what I'm talking about. So we're going to probe the corner of the vise there, right in front of where the ruby is. But yeah, pretty close. Probably should have done that prior to putting the block in, but oh well. Alright, I set this one to be a little bit slower just because we got that thinner hot top hat. So a little bit slower feed and a little bit less with the cut, but still pretty quick. Cool, so that's what I was talking about. We are start to leave, just like yesterday's video. We got this nice, not touching our finished sidewall, and we'll just come here and deck it off, and nobody will get hurt, we think. So we got it all faced. Oh, hold on. Gotta turn the jams off. Wouldn't want Google knocking down my door. Alright, so faced it down, good finish and all. Now we're going to chamfer this side, and a good tell to make sure that your work coordinate system and your vise is actually square is if your chamfers line up, and we're about to find out, aren't we? Crunch. Whoops. Sweet, so you can see the chamfers are equal even around the rings. So that means we were pretty much dead nuts on that flip, which is a good sign. Alright, so now we're going to have this surface facing upwards, and we're going to drill tap and do all that other fancy stuff and the scary flow tool path. Cool, so here it is set up for OP3. We're just going to use the G54 because it's center, and the Z hasn't changed this entire time, which makes it nice and easy. So probe it in center, and then we're going to drill, spot, drill, and then tap, and then we'll do the flow toolpath, and hopefully not break anything. I think I already said that. Alright, just got it probed in, so now we're going to start our toolpath. I feel like I'm being really redundant. There she is, the golden child. It's actually not a 1/2 inch drill, it's like 4.7, no wait, it's some sort of metric size drill. I bought it when I didn't know what I was doing. I was like, that's close to 1/2 inch. It was really expensive too. It is carbide, but I've had it in the machine for over a year. Works good. Probably didn't need to peck this one just because there's a, it's going into the bore, so I mean, it would have been okay, I guess. But, and it's such a short distance. Live and learn. Hopefully we don't hit the parallels on the side holes. Probably should have thought of that earlier. I could stop it right now. Wait a minute. Weren't you supposed to drill those holes? I guess I forgot. Oh well, we'll go through the motions first. You know what's funny? This sounds so much better in 60 series than it did in 70 series yesterday. The 70 series was pretty like gummy, it seemed. Like over 100% spindle load on the retract, which is kind of weird. But that went pretty good. Alright, just gonna chamfer. I'll skip this part and then we'll go on to the final boss, the flow. So this might be hard to see. Oh, actually it's pretty easy to see. So if you look down the bores of those, you can see where the drill and the tap exited. And so obviously our tool is not going to fit very good anymore. So my thinking is if I come in there with a lollipop endmill, which literally looks like a lollipop, we might be able to deburr the backside without having to do it by hand and messing up the bore itself. And deburring those by hand, I don't really have a backside deburring tool, I think, that can do those. So we're going to give this a shot, and I've never done this, but it could be pretty interesting and pretty cool, I guess. So basically the tool is going to come in and attempt to follow that bore curve and deburr our circle at the same time. So we'll see. So that's the tool. Looks like a ball end mill with the shank removed. That's basically what it is actually. But they're very expensive. I mean, that's $40+ I think for that 1/8 ball. And I use that for titanium, so. But yeah. Probably don't need coolant for this here guy. I'm gonna make sure the first one goes good and then we'll watch it. I guess we're both gonna watch it. Oh yeah, that went great. Oh, whoops. Well, as you can see, something didn't go right. Well, actually, see, I'm not really sure what went wrong because I had it modeled in Fusion properly, so maybe the collet's actually different from the one that's in Fusion. Kinda weird. Like, really, really super weird. So, yeah, I'm gonna check it out, but for now, to clean up our little boo-boo here, I'm just gonna deck it off a little bit and see if we can just clean up these sharp edges and then continue about our day like nothing ever happened. Okay, I figured it out. When I made sure that the length below holder was correct, it's 0.5 on Infusion, and it obviously looks good in simulation. Well, I actually was looking at shoulder length, and it's 0.45, so that's where the confusion came in because I thought, oh, 325? 4 or 5? Miles, baby. Miles. Well, in reality, not miles. Yeah. Perfect. Let's try again. Alright, boys, we're back in the ring. Definitely gonna stop it a little sooner this time. Perfect. Successful after the blunder, but there's still burrs on the inside. So I'm still gonna have to hand deburr it. The ball's not, it's not big enough, basically, to deburr, I think, without hitting the shaft of it. So I'll have to figure out something. But basically, last thing, drill these 2 holes and then re-chamfer this so we can clean up this little boo-boo and take it out and see what we got. Okay, let's see. So here's what we wound up with. Our beautiful part minus this really awesome looking artistic feature. So these are the burrs that I'm telling you about. Yeah, you see those? Now, I did notice something. The cool thing is, because the tool is flat, it actually kind of just ignores those burrs. Let me grab one that's not dirty. So you got the flat, and then up on the top here. Good stuff, good stuff. That's cool. So, yeah, so basically you got quarter 20s that are going to hold the tool in there, and it'll face like this. And let's make sure it actually fits on our block. So remember we did those tapped holes on the back side. That's what that was for. Well, hopefully this works. So I think it's mirrored, so I can kind of pick whatever side I want. So we're going to put the bad side up because it's got material that's now sticking over the edge. And this bottom side is actually going to rest flat on whatever device we choose. So when I go to actually install it, we're going to loosen the bolts up and then have it sit flush. Let me go grab some screws. So these are just quarter 20s you can buy from McMaster. I buy them in the, you know, the 100 lot or whatever. And I like to, the cool thing is you can model, there's a McMaster catalog on Fusion, so you can have them all modeled up, which is actually really helpful and helps both me and McMaster, 1, for them to sell things, and 2, for me to have actual working models of things. Let's grab a thing. Where is the right size key? This is a good sign because that means tomorrow is actually figure out how to make this work day. Very cool, very cool. Let's take one of our here tools. I'm gonna go like this, and that's just gonna sit like that. I like to have a nice large assortment of fasteners on hand. It makes building fixtures really easy. So these are just gonna, they're not gonna sit down all the way, but they're just gonna, they're like set screws basically. So they're just gonna hold our tool in there from moving, and the bore is what's gonna keep it from, you know, moving left and right or whatever. I actually think our lollipop hit the threads because they don't look as clean as they originally did, but I digress. I actually don't know what that means, but I know what it means in context, but not necessarily the definition of digress. So, yeah, there she is. Let's get me in the picture. That'd be cool. I, the creator of this fine piece of equipment, that's me. Alright, anyways, so yeah, this has been a fun part 2 of this this here lathe tool series, but actually came out pretty good. It took longer than I expected. Actually, no, it took exactly as long as I thought it was going to take, but this is where we're at, this is a good progress, I guess, for the weekend. Tomorrow's Sunday, so I got definitely plenty of time to figure out the cam side of this endeavor, and I'll be filming that. So yeah, thanks for watching. I also post a lot on Instagram, so if you want to check out me on Instagram, it's the same username. It's pretty, make it universal, make it easy for us people to follow me. So cool, catch you on the next one.